Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing sequences and we shall be dealing with comprehensive questions. The table shows the first four terms in sequences A, B, C, and D. Complete the table. So the idea in questions that are chosen to be in this video is that they do not tell you what type of sequence this is, and you have many different types of sequences within the same question. So we're going to be reviewing everything we discussed previously about linear sequences and non-linear sequences. So for the first sequence, we have 16, 25, 36, and 49. Let's write them down below. 16, 25, 36, and 49. If we go from one term to the next, we can see that here we add 9, here we add 11, here we add 13. So for the next layer, we can see that this is plus 2, and this is plus 2 as well. So the difference in the second layer is the same. So therefore, this is a quadratic sequence. We're going to write down n and n squared and un. So for n, we have 1, 2, 3, 4. For n squared, we have 1, 4, 9, and 16. For un, we have 16, 25, 36, and 49. We need to figure out the relationship between n squared and un. So here, this is plus 15. From 4 to 25, this is plus 21. From 9 to 36, this is plus 27. So we need to figure out what this sequence is. We have 15, 21, and 27. We can tell here that the sequence here is linear. So this is plus 6, and this is plus 6 as well. So un equals an plus b. When n is 1, un is 15. And the a is always 6. So we can get the b. 15 minus 6 tells us that b equals 9, because 15 minus 6 is 9. So therefore, the sequence here is 6n plus 9. So the sequence in black here would be 6n plus 9. And of course, we have here n squared. So n squared plus 6n plus 9 is the formula for the nth term. Of course, you can factorize this into n plus 3 all squared, but both answers are correct. Now, for the fifth term, you can just put n as 5. So 5 plus 3 is 8. 8 power 2 is 64. So this is here 64. Or you could have just noticed the pattern. We have plus 9, plus 11, plus 13. So we can do here plus 15. Again, this will give us 64. So you can either get the fifth term first and then the nth term, or you can do it the other way around. Both of them are correct. So let's just check the answer to sequence A so that we can clear the screen and give ourselves space to work out the rest of the sequences. So for the sequence A, we have 64 and n plus 3 all squared. These are both correct. And now we can move on to sequence B. Now in sequence B, we have 5, 8, 11, 14. So let's write these down. 5, 8, 11, and 14. Now, if we start with the differences, we get plus 3, and plus 3. So here, this is a linear sequence because the difference is common at the first layer. So we write un equals an plus b. And un equals 5, a equals 3, n is 1. And we want to get b, so 5 minus 3, so b is equal to 2. 2 would be the correct answer here for B, and therefore the nth term is going to be 3n plus B. Of course, again, you can either here do plus 3 to get 17, or you can just put n here as 5 and B. So, excuse me, of course, this is not B, this is 2. I apologize for that. We already said that B equals to 2. So if you put n as 5, you get 3 times 5, which is 15, plus 2, which is again 17. So you are sure that you are correct. So 17 and 3n plus 2 for the second sequence. These are the correct answers. 17 and 3n plus 2 are correct. Next, we have a sequence 11, 17, 25, 35. So let's write that down and attempt to analyze it. We have 11, 17, 25, and 35. So to go from 11 to 17, we do plus 6. 25 minus 17 would be 8. 35 minus 25 is 10. So at the first layer, the differences are not the same. However, if we get the second layer of differences here, we have plus 2 and plus 2 again. So this seems to be another quadratic sequence. Now, for the quadratic sequence, we have the table n squared, and un. So 1, 2, 3, 4, 1, 4, 9, and 16. This is 4 here. And we list the elements of the sequence, which are 11, 17, 25, and 35. So to go from 1 to 11, you do plus 10. Here you do plus 13. From 9 to 25, so 25 minus 9, this gives us 16. From 35 to 16, this is 19, so plus 19. So our sequence is 10, 13, 16, and 19. Our formula is un equals an plus b. Un is 10. A is the common difference here. So the common difference is plus 3. I forgot to do that. I apologize. So the common difference is plus 3, and therefore the A is equal to 3. And the N is always 1. So plus B. We do 10 minus 3 to get B. So B equals to 7. So therefore, the sequence here in black in the table is 3n plus 7. And therefore, we have here n squared plus 3n plus 7. If you put n here as 5, you get 25 plus 15 plus 7, and this gives you 47. So we have 47, which is the correct answer to the fifth term, and we have a different expression for the sequence. However, these two expressions are equivalent. So if you attempt to simplify their expression, you get n squared plus 6n plus 9 minus 3n minus 2, which is the same as n squared plus 3n plus 7. So our two answers are both correct. Maybe they just did it in a different way, and therefore they got the expression that they got. However, both answers are correct. Finally, for sequence D, we're going to solve each sequence on its own. The numerator has the sequence 3, 4, 5, 6. The denominator has 2, 3, 4, 5. Of course, this is quite simple. These are two linear sequences, and n is 1. I mean, a is 1. The common difference is always plus 1. So the new term here is 7. The new term here is 6. So this is 7 over 6, obviously. And you can just get the formula for the sequence using an plus b equals un. So for the first sequence, we put here 3. We put here 1. We put here 1 as well. Plus b. So 1 plus b equals 3. So b equals to 2. So therefore, the sequence is 1n plus 2 or just n plus 2. So in the numerator, you can just put n plus 2. And then for the denominator, you have 2, 3, 4, 5. Again, un equals an plus b. You can put in un the 2 equals, and here the difference is 1, and n is 1 as well, plus b. So b equals 2 minus 1, which is 1. So therefore, the sequence here is un equals n plus 1. So we have in the denominator n plus 1. And if you plug 5 instead of n in this expression, you get 7/6. So we know that we are on the right track. So 7/6 is correct, and n plus 2 over n plus 1 is correct as well. This is another question of the same type. The table shows the first 5 terms of the sequences A, B, and C. Complete the table for the 6th term of each sequence. So here, for the first question, we just need to get the new term. You can just figure out the pattern. From 3 to 4, you have plus 1. From 4 to 5, you have plus 1 as well, plus 1, plus 1. So this is going to be 8. Here we have plus 1, plus 1. Excuse me, plus 1 and then plus 3, and then plus 5, and then plus 7. So here it's going to be plus 9. The sequence is 1, 3, 5, 7. So 16 plus 9 gives us 25 as a final answer. Here we have plus 0, plus 2, plus 4, plus 6. So you get plus 8. 9 plus 8 is 17. If you don't quite understand how I got these numbers and you're more comfortable getting the expressions of the sequences, that would work as well. So it might actually be a good idea to just get the expressions of A and B and C before attempting even to solve the rest of the question. So for sequence A, this is a linear sequence because we have plus 1 in all of the terms. So therefore, we're going to write un equals an plus b. And un here for the first term is 3. And this means that n is 1, of course, and a is plus 1, so we just write 1 here for a. So 3 equals 1 plus b, so b equals to 2. So the sequence for a is un equals n plus 2. This is the expression of sequence A. And then for sequence B, we know that we have the difference is not common. So let's just write down sequence B here. So sequence B is 0, 1, 4, 9. And we said that here we have plus 1, plus 3, plus 5. But we know that the second layer of differences will be plus 2 in both cases. So this is a quadratic sequence. So we can quickly write down the table for the quadratic sequence. We have n and n squared and un. We have 1, 2, 3, 4, 1, 4, 9, and 16. And un is 0, 1, 4, 9. So the relationship between n squared and un here would be minus 1, minus 3, minus 5, and minus 7. So our sequence here is 1, 3, or negative 1, negative 3, negative 5, negative 7. There is a common difference here of negative 2. So we can figure out the formula for the sequence. So un equals an plus b. Again, un is negative 1, a is negative 2, n is 1. And then we have plus b. We take the negative 2 to the other side. So negative 1 plus 2 is positive 1. So 1 equals to b. Therefore, the sequence is negative 2 n plus 1. So the part that relates n squared to un is negative 2n plus 1. And of course, here we have n squared. So the final formula for sequence B can be written as UN equals n squared minus 2n plus 1. And if you try plugging n here as 6, you get U6 equals 6 squared minus 2 times 6 plus 1. This is 36 minus 12 plus 1. And this is 25. And this matches the number that we got for the sixth term in B. We got 25 here. And this comforts us that we are on the right track. We're going to do a similar operation for sequence C. So for sequence C, we have -3, -3, -1, and 3. And we said that we have here +0, +2, and then +4. So on the second layer, we have +2 and +2 again. So this is a quadratic sequence. We can create the table n squared and un. So 1, 2, 3, 4, 1, 4, 9, and 16. And un here is -3, -3, -1, and 3. So to go from 1 to -3, you do -4. From 4 to -3, that's -1. From 9 to -1, excuse me, from 4 to -3, that's -7, because -3 minus 4 is -7. And then -1 minus 9, that would be -10. And 3 minus 16 would be -13. So our sequence here is -4, -7, -10, and -13. So -7 minus -4, you're actually subtracting 3 each time. And this is a linear sequence, so un equals an plus b. Here for un, this is -4. The a is -3, and the n is 1. If we take 3 to the -3 to the other side, it becomes +3. So -4 plus 3 equals to b. So b equals to -1. This is the value of b. So therefore, the sequence here is -3n minus 1. This is the sequence. And of course, you have to add the n squared itself. So let me just put the sequences in circles so that you understand what's going on. This is the sequence for B. And for C, the sequence is going to be n squared minus 3n minus 1. Again, if you put 6 here, you get 36 minus 18 minus 1. And this gives us 17 as we got in the table. So doing this actually solves half of the problem because we are asked to find the nth term in each sequence. So for B, the nth term, question B, I mean, the nth term of sequence A has already been obtained. It's n plus 2. So we can immediately write this down. And for sequence B, the nth term is n squared minus 2n plus 1. And for sequence C, the nth term is n squared minus 3n minus 1. The reason why I did them without reading the question was to tell you that if you don't know how to figure out the sixth term of the table, if you don't know how to figure this term out, you can just get the 3 expressions for A, B, and C, and then you can just plug n equals 6 in each of them, and they will still give you the correct answers for the table. So you can get the 3 expressions first and then fill in the table if you don't know how to get the numbers straight away. Now that we found these 3 expressions, all we have to do is just solve Cii and Dii, and these are quite straightforward questions. Let's just figure them out very quickly. For Cii, we want the value of n when the nth term of sequence B is 8281. So we want n, so we just write 8281 equals the expression we found in I, which is n squared minus 2n plus 1. We can take this to the other side, so we get 0 equals n squared minus 2n minus, so 1 minus 8,281 gives us 8,280. And then you can simply use mode 5.3 on your calculator in order to figure this out. This is what I'm about to do right now. So in A, we put 1, in B, we put -2, and in C, we put -8,280. And we get -90 and 92 as the possible values of n. So -90 and 92 are both solutions to this equation. However, we're going to take the positive value because n cannot be negative, like we said before. So n equals 92. For Dii, we want the 8th term. So 8th term means n equals 8. They gave us the index and they want the value. Bear in mind that in Cii, they gave us the value and they wanted the index. The index is n. So if they're asking for n, they're asking for the index. However, here they told us the 8th. So 8th is index. So they're giving us the index. So n equals 8. And we are expected to find the value. So all you have to do is just plug 8 into the expression for sequence C. So we have 8 squared minus 3 times 8 minus 1. So 64 minus 24 minus 1. And this gives us 39 as the final answer. So let's check the marking scheme. We have 8 and 25 and 17 for the first 3. So these are correct values here. And then we have n plus 2. This is correct as well. Here we have n minus 1 squared. Of course, this can be simplified into n minus 1 squared. So this is correct as well. It doesn't matter. You don't have to simplify it. You don't have to factorize. Both expressions would work as correct answers here. So this is fine and this is fine. And then we have 92. And n squared minus 3n minus 1 is correct. And finally, the 39 is correct as well. Again, here we have sequences and we want to complete the table for each sequence. So for the first sequence, we have 15, 8, 1. So to go from 15 to 8, you minus 7, here you minus 7, and here you minus 7. So this is a linear sequence. Un equals an plus b. The first term is 15. The a is -7, and n is 1. We have plus b. We take the -7 to the other side, so we get 22 equals b. So therefore, the nth term is going to be -7n plus 22. You can get the 5th term and 6th term either by plugging 5 and 6 into n. This would work, or you can just do -7 twice. So here, if you have -7, we get -13. -7 again, we get -20. So if you plug n equals 5, you will get -13. If you plug n equals 6, you're going to get -20 as well. For B, we have a rational sequence. So again, we said we deal with the numerator on its own. So we have 5, 6, 7, 8. So this is quite simple. I'm just going to write here these answers. We have 9 and 10. And for the denominator, we have 18, 19, 20, 21. So all you have to do is add 1. So you have 22 and 23. These are quite straightforward to calculate. So here I have +1. And here I have +1 as well. I'm going to teach you a quick way to get the an plus b. You don't have to do it. You can just use the standard way, but it's just a very quick way of solving. So we said un equals an plus b, and our target is to find a and b. A is the common difference, so it's plus 1. To get B in a very quick way, you just get like the 0th term only in linear sequences. So if you want to get B here, you just do minus 1. So what plus 1 equals 5? This is 4. And for the 18, something plus 1 equals 18. So this would be 17. This is the value of the B. So how does this help us? We can immediately write the formula for the sequence as n plus 4 over n plus 17. Of course, you can do it using the standard way. So for the numerator, for example, I have 5, 6, 7, 8. We know that this is plus 1. We can write an plus b equals to un. We can put un here as 5. And this is equal to 1. And this is equal to 1 plus b. So you take this to the other side. So 5 minus 1 equals b. And therefore b equals 4. And therefore un equals to 1n plus 4, which is what we got here. So it was just a quick way. The quick way is simply just moving one step back. You do minus 1 here, you just get 4, and then that's the b. That's a quick way of finding the b for linear sequences. So anyway, moving on, we have here for sequence C, we have plus 3, plus 5, plus 7. And then the difference at the second layer will be plus 2, plus 2. So to get the new terms, you can just say, so the difference here is plus 2. So it becomes plus 9. And then the difference here is plus 2. So we have plus 11. So 17 plus 9 is 26. 26 plus 11 is 37. This is a quick way of getting the table values, 26 and 37, because we have plus 3 plus 5 plus 7, so plus 9 plus 11. Now to get the nth term, since the common difference is at the second layer, we know that this is a quadratic sequence. So I'm going to do the table for the quadratic sequence. For the quadratic sequence, we have we have n squared, and un. 1, 2, 3, 4, 1, 4, 9, and 16. We have here 2, 5, 10, 17. We want to assess the relationship between n squared and un. So you can see here that it's always plus 1, plus 1, plus 1, plus 1. So the expression for un is simply n squared plus 1. So we have here n squared plus 1 as a final answer. For the final sequence, sequence D, we have plus 4, plus 4, 2 plus 4 equals 6. 6 plus 12 is 18. 18 plus something equals 54. So you do 54 minus 18, and that gives you 36. Now, 4 and 12 and 36 are obviously different numbers. If we get a second layer of differences, we have here plus 8, and we have 36 minus 12, which is plus 24. Now, from 8 to 24, 24 minus 8 would be 16. So you can see here that there is no common difference at the first layer or the second layer or the third layer. We don't even have enough values to determine whether the third layer has common differences or not. So when the differences don't work, you have to start thinking about the times. So the times, if we go from 2 to 6, we have times 3. If you go from 6 to 18, we have times 3. 18 to 54, we have times 3 as well. So this tells us that this is an exponential sequence, and all the plus values were irrelevant here. We just had to do times 3 times 3 times 3. And the formula of exponential sequences is un equals a power n times b. So therefore, all you have to do now is plug a as 3, because we're doing times 3, and n is 1, and un will be 2. So 2 equals 3 power 1 times b. So b equals 2 over 3. So therefore, un equals 3 power n times 2 over 3. Of course, we can further simplify this because we have 3 power n in the numerator and 3 in the denominator. So we can simplify these two together using exponential simplification. This becomes 3 power n minus 1 times 2. So the final answer for this sequence would be 2 open brackets 3 power n minus 1 like this. Or you can write it in the same way I wrote it here, 3 power n minus 1 times 2. This would work. Now for the new terms, you can just do times 3, of course, here. So 54 times 3 is 162. And then you can do times 3 again. So you can use your calculator for this, or you can do it mentally, that's up to you. So 162 times 3 on the calculator will give us the following. 162 times 3 gives us 486 as a final answer. So these are the terms of the table. Now we can check the marking scheme. So we have negative 13, negative 20, negative 7, n plus 22. So these are correct. We have 9 over 22 and 10 over 23, and n plus 4 over n plus 17, 26 and 37, and n squared plus 1, 162, 486, and 2 times 3 power n minus 1. So our answers seem to be correct. Complete the table for the 4 sequences A, B, C, and D. Again, we have to test each sequence independently. So for A, we have plus 3, plus 3, plus 3. So the next term would be 14. We do plus 3 again. And this is obviously a linear sequence. So I told you before, linear sequences, you can just get the equation even mentally. It's going to be 3n plus b. What is b? So to get b, you can just simply go back one step. So something plus 3 equals to 2. So basically, you're doing minus 3 here. So 2 minus 3 gives us negative 1. So 3n plus negative 1. Or of course, you can rewrite it as 3n minus 1. This looks nicer than what we wrote before. So 3n minus 1 would work. For the second sequence, we have 20 minus 6 equals 14. 14 minus 6, and here minus 6 as well. So minus 6, again, we would get negative 4. Now to get the b, we need to have something minus 6 equals 20. So you're moving in the opposite direction. You do plus 6. So the b here would be 26. So the final answer would be negative 4n plus 26. This is a quick way of solving linear sequences. Of course, I explained the slow way in a previous video, and there are a lot of problems that you can solve using the slow way to practice first. But this here, because this is an advanced video, so we're just using the quick way to solve. Now, for the sequence C, we have 1 plus 3 equals 4. 4 plus 5 equals 9. 9 plus 7 equals 16. At the second layer, we have plus 2 plus 2. So this is a quadratic sequence. If we add plus 2 here, we get plus 9 at the first layer. So 16 plus 9 gives us 25. And then we want to get the quadratic sequence. So we have n, un, sorry. So n and n squared first, and then un. We have 1, 2, 3, and 4. And then for n squared, we have 1, 4, 9, and 16. And then for un, we have 1, 4, 9, and 16 again. So there is no relationship whatsoever. I mean, there is no new relationship. It's just exactly the same. N squared is exactly the same as un. So therefore, the expression is simply n squared. Of course, you could have done this mentally. You could have just looked at the sequence and thought to yourself 1, 4, 9, 16. So we're basically just using the square numbers, the perfect squares. So that would have been okay. But I don't solve mentally here. I just try to explain the standard way of doing everything. So in sequence D, you have 0, 2, 6, 12. So from 0 to 2, you have +2, +4, and +6. At the second level, you have +2 and +2 again. So you have +2 here at the second level. So we go up one level, we do +8. So 12 plus 8 is equal to 20. And again, we need the same table because this is a quadratic sequence. So n squared un. We have 1, 2, 3, 4, 1, 4, 9, and 16. And then our terms are 0, 2, 6, and 12. So here we have -1, -2, -3, and -4. We can create a sequence out of these numbers. And we know that this is a linear sequence because we are subtracting 1 every time. So un equals an plus b. We already know that the a is -1, so -1n plus the b. And to get the b, we said that here it's -1 as well. So in the opposite direction, it would be +1, -1 plus 1. These two together gives us 0. So b here is actually 0. So this is just -n. So the sequence here is -n. And of course, this is n squared. So n squared minus n would work. And this will be our final answer. If you want to check your answer, you can just put n as 5 because the next term here is the fifth term. Here we have, this is the fifth term. So if you put n as 5 in any of the expressions, you should get the column to the left. So if we put n equals to 5, we get 15 minus 1, so this is correct. N equals to 5 here as well. -20 minus, -20 plus 26. So here we seem to have made a mistake. Yes, because this is negative, it's not -4n. This was my mistake. This is actually -6n. So it's a good thing to check your answers like I did because I saw my mistake. I figured out my mistake by checking. So because here the difference was -6, not -4, it was a silly mistake that I made. We were supposed to write -6n plus 26, not -4n plus 26. Now, if you put 5, you get -30 plus 26, which is -4. In the third one here, you put n equals 5. So 5 power 2 is 25, so this is correct as well. Finally, in the fourth one, if you put 5, you have 25 minus 5, which is 20. So now we're confident that the nth term expressions are correct. So it's a good idea to first get the next term using logic, and then get the nth term using what we discussed before, and then check the correctness of your answer by making sure that the two columns match together. And we're expecting now to have the correct answers since the columns match, and indeed we do. So we're going to move on to the final question in this video. Complete the table again for the fifth term and the nth term of each sequence. So one final time, we have a sequence here, 9, 5, 1, -3. This is -4 in all of them. So we know that if we put -4 here, we get -7. So -3 minus 4 is -7. For the second sequence, we have 4, 9, 16, 25. So we have here +5, +7, +9. So at the second layer, we have +2, +2. So we have +2 here as well. 9 plus 2 is 11. So we add 11 here and we get 36. For the third sequence, we have 1, 8, 27. Let's try again. So we have +7 here. From 8 to 27, this is 19. From 27 to 64, you subtract 64 minus 27, you get 7, so you get 37. So at the second layer, from 7 to 19, you have +12. From 19 to 37, you have 18. Of course, here, if we were to continue, from 12 to 18, you have +6. So this is a cubic sequence because the first two layers did not work, so probably the third layer will. So if you add plus 6 here, 18 plus 6 gives you 24. So if you add 37 to 24, you get 61. So we're going to add 61 here. And this gives us 125. So this actually works out as a cubic sequence because 1 is 1 power 3, this is 2 power 3, this is 3 power 3, 4 power 3, and this is also 5 power 3. It's easier in this particular case to just do it mentally and to write the expression here as n power 3. It's just easier this way. But anyway, so for the fourth sequence, you have plus 8, and you have here, excuse me, so you have plus 8 here, and from 16 to 32, you have plus 16, and from 32 here, you have plus 32. So you can see that the difference is not the same. So here again, you have plus 8, and from 16 to 32, you have plus 16. It's not really working out. So you can try multiplying instead. If you do times 2 here, you find that it works. So this is an exponential sequence. So we don't need the differences here. So we can do an extra times 2 to get the new term. So times 2 here, and we get 128 for the next term. Now we want to work on getting the nth term expressions. So for the first one, we have an plus b. To get the a, we just look at the common difference here. So it's -4. So -4n plus b. And to get the b, we said we just move one step to the back. So we want something -4 equals 9. So we just do +4 and we get 13. 13 would be the value of b. So -4n plus 13. This would be our final answer. Let's just circle the final answers here so that when we're comparing to the marking scheme, we know where to look. Now for the second sequence, we have 5, 7, 9, and then 2, 2, 2. So this is a quadratic sequence. So we need to do the table for n and n squared. So 1, 2, 3, 4, 1, 4, 9, and 16. And then we write down the terms of the second sequence. They are 4, 9, 16. So we just add 3, we add 5, and we add 7. So we have a sequence of 3, 5, 7. We're adding 2 here every time. So this is 2n plus b. And the value of b is obtained by getting one term before. So it's 1, so 2n plus 1. So therefore here, the sequence that we have is plus 2n plus 1. We just bring down the n squared, and this is our final expression. So we put here n squared plus 2n plus 1. And cross this out, of course, this is not part of the final answer. And we have the final answer here as well. Finally, for the exponential sequence, we should know that it's a power n times b. So for a power n, the a is the 2 because it's times 2 every time. So it's 2 power n times b. And we put 8 for the first term, and then we put 1. To get b, we divide by 2. So this goes out, and this becomes 8 over 2. So b equals to 4. So therefore, the answer is 2 power n times 4. And of course, you can further simplify it because 4 is the same as 2 power 2. So 2 power n times 2 power 2 gives us 2 power n plus 2. So this is the same as 2 power n plus 2. Either format would work for the final answer here. So A seems correct. B seems correct as well. C is 125 and n power 3. And the final one is 128 and 2 power n plus 2. So these seem to be all in order. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.